Hello, student. For this online week, I will be covering section 8.4 and hopefully also 8.5 to get you a head start on what you will be learning in after Thanksgiving break. Section 8.4 is the radical expression with several terms. Okay, several terms mean that you may have radicals that have different radical in there. Like for example, the root of 5 and the root of 3 as opposed to root of 6 and here. So if you want to think about adding and subtracting radical expression, think about how we add and subtract polynomial. Okay, remember when you add and subtract polynomial, we can only do so when they are like terms. Okay, so you can think about treating radicals as a term in similar manner. Okay, so I give some examples here. Like radicals mean that it has not only the same exact square root, okay, or cube root or fourth root, but the inside, which is the radicand, has to be exactly the same also. Okay, and when you add or subtract, you simply take the number directly outside of it and add or subtract. Okay, this is an example of an unlike radicals. 8 radical square root of 5 and 5 square root of 3 are not like radicals because the 5 and the 3 are not the same. Okay, so let's take a look at some examples here. Example 1a, you can see here that 4 root 7 plus 6 root 7. You can see that they have the same like radicals, so what you would need to do is just take 4 plus 6. Okay, so 4 plus 6 is 10. 10 what? 10 root 7. Okay, just thinking about, okay, if you think about polynomial, you remember I said that 4s plus 7s is going to be, not 7s, 6s. I want to make it look the same as the other one. Okay, so 4s plus 6s equal to 10s. You carry the s over, you carry the like term over. So in the same manner, you're going to do the same thing for the radicals as well. Okay. Over here, you can see that you have the root of m and you have 2 minus 3. 2 minus 3 means negative 1. Okay, you can write down negative 1 square root of m, or you can write down the negative square root of m. Okay, and the 1 can be invisible or implied. Next examples. Look at C. You can see that 8 plus 4 square root of 5, both of them are not like terms, okay, because the 8 do not have the square root of 5, not 8 times square root of 5. So you really can't do anything here. You cannot take 8 plus 4, even though this is the number outside, but it has to be like radical. So this would be the answer right here. Okay. In the example D, you notice that you have a square root of 10 and square root of 6. One way you can try to see if you can simplify any of the radicals to make sure, to end up having the same radical inside the radicals. Well, you can't really simplify the 10 because there's no number that you can think of that is multiplying, that is the square root, not the square root, the square number multiplying another number should be equal to 10. So technically, this is already simplified as well. And you can't really add them. Next example. You can see that we can have 3 terms. We can have 5, and but there's no number here. It means it's 1 times square root of 14, and then minus 9. So just do PEMDAS. 5 plus 1 is 6. 6 minus 9 is negative 3. Negative 3 what? 3 square root of 14. Okay, you probably wonder why didn't I simplify see if I can simplify the square root of 14. Well, I can't think of a perfect square that multiplies to be equal to 14. So I know that I cannot simplify anything inside the radicals. Okay, so that would be my answer. And in this situation right here, it's a similar manner. It will be 6 plus 1. Let me see, put 1 here. Square root of 2 minus 10. And the result is going to be 6 plus 1 is 7 minus 10 is negative 3 radical 2. Okay. All right, so those are some examples of adding and subtracting radicals. What if the radicals are not alike? Just like how I did with example D right here. You can see that in example D, the radical is not alike, but I can't really do anything to simplify it either. In the example number 2a or beyond, you can see that I have the 18, the square root of 18 and square root of 8. I can think about the square root of 18 as 9 times 2. Now you probably wonder, why 9 times 2? Well, because 9 is a perfect square. And I know that 9, I can take the square root of 9 out of 3 square root of 2. Okay? And in terms of square root of 8, I can think about 4 times 2 because 4 is a perfect square. Okay? So you need to go back and review what being a perfect square means. Okay, perfect square means you're going to have an integer multiplying itself to be equal to some product, and that product is considered a perfect square. So like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. So then 1, 4, 9, 16, 25 are considered a perfect square. Okay, so the square root of 4 is 2, so I'm going to write down 2 without it inside the radical, and then having the square root of 2 here. So when I simplify it like that, you can see that I have 3 square root of 2 plus 2 square root of 2, and that will give me 5 square root of 2. Okay, next one. You can continue to simplify it. I will leave the problem B for you to do on your own, but I will go ahead and do C, and let's see, C and F, and then you can do B, D, E on your own, so that in the next video, I will show you the solution to those problems, okay? Okay, so let's put T to C here. 44, well, I can think of 4 times 11. And then I have S squared. Okay. And I can have 99 mean 9 times 11. Okay. So 4 times, and remember that when I have this, something like this, it means that I have a pair. So I can take a pair out as I can take out the 4 as the square root of 4, which is 2. And then 11, I will put it back inside because you really can't take out anything that is the square root of 11. 9, I can take out a 3, and I have the s outside, and I have square root of 11. So you can see here that I have 2s plus 3s is 5s square root of 11. Okay, so that would be the answer. Now, on the side, I'm going to use a different color here. Let's look at this example then. Let's say I have simplified and I turn out to have 2s square root of 11. And then I would have 3 with no s but square root of 11. Can I combine those two? The answer is no, even though it had the same radicals, okay, square root of 11, both, but you cannot add 2s plus 3. So in other words, when you combine like term, like radical, you also have to consider thinking about combining like term on the outside as well. So that's why in this situation right here, this is the answer. Okay, so just keep that in mind. The next example that I will do is F right here. You can see that the square root of, let me do a different color. The square root of y squared is going to be y. So I'm going to have 4y. And then minus the square root of 6y. Really, I can't take out anything, so I'm going to write it down. Plus the square root of 6, the 6 times square root of y, excuse me. And then minus 9. You can see that this is like term right here. And it's going to cancel out, okay? And then I end up having 4 minus 9. 4y minus 9. Simple. Okay, so now it's your turn to go ahead and try B, D, and E. And then on the next video, you will be able to see the solution that you can double check on. Okay, I'll see you on the next video.